this is B. Naresh, working as Assistant Professor in ECA department. So today's topic is problems on common collector transistor amplifier analysis. So in this session, we are going to discuss some of the problems that is related to common collector transistor amplifier using the low frequency model analysis. So in that, we will see the first problem. For the emitter follower, so means that the emitter follower circuit, common collector is also called as the emitter follower circuit. As shown in below figure, the circuit parameters are, so they are given specifications are source resistance, RS means source resistance, that is 500 ohms, and R1, R2 is defined as 50 kilo ohms, RL is 2 kilo ohms, HFE is 100, and HAE is 1.1 kilo ohms. Determine the input resistance, output resistance, current gain, and voltage gain. For these given specifications, the given circuit is this one. So in that, they are using that a common emitter follower circuit, or it is also called as common collector circuit configuration. Hence, so we are measuring the output across the emitter, and the collector terminal is a common for input side and the output side. And the base terminal here it is acts as the input side, and the emitter is acts as the output. And for this case, the given specifications are the source side, the input resistance is defined as 500 ohms, and they use the voltage divider network. So for this case, R1 and R2, both the resistances are represented as 50 kilo ohms. Then they are given that a forward current gain, HFE, and HAE means input impedance is defined as 1.1 kilo ohms. Based on this, we need to calculate input resistance and output resistance, and we need to calculate the current gain as well as the voltage gain. So we'll see in detail. So let us assume the first the given specifications. So here I represented that the given specifications are the source resistance is 500 ohms, and the potential divider network contains R1 and R2 is 50 kilo ohms, RL is 2 kilo ohms, HFE is 100, and HAE is 1.1 kilo ohms. Now first we need to calculate the input impedance as per the given small signal model analysis. So we know that one, the input impedance, so the output side is represented as IC is equal to beta times of IB plus 1 plus beta times of IC naught. And from this, then based on the small signal model analysis, RA is represented as HIE plus 1 plus HFE times of RL. There they are represented that HIE is a known parameter, HFE is also known parameter, RL is a known parameter. Now we need to substitute the given values. HIE is 100 plus 1 plus HFE is represented as 100 again. So sorry, HIE is 1.1 kilo ohms here. The HIE is 1.1 kilo ohms, means 1.1 into 10 power 3 plus 1 plus HFE value is 100 into the load resistance is 2 kilo ohms. Then can simplify this one. It gives that the input impedance is 203.1 kilo ohms. That is the input impedance for common collector amplifier for the given specifications. Similar to that, we need to calculate the total input impedance for the input side. So for this case, if you observe the total input impedance, we have that, so means this is represented as HIE, and this is represented as, so it contains HIE, and then we have this a reverse voltage gain HRE, and this is a forward current gain HFE, and output side we have this output admittance HOE, and here the collector current is a flows, this is emitter, and this is the input side VI, and here at this point we connected that so all the input resistances means along with RA, and it internally the circuit contains a potential divider network, that is R1 and R2. So if you observe the given circuit, so here we have this potential divider network R1 and R2, Along with this RS, we observe that the input impedance. Hence, if you want to determine the total input impedance, that Ri dash is a parallel combination of Ri along with R1 and R2. So means that what is Ra value? This 203.1 kilo ohms is parallel with R1 is 50 kilo ohms and R2 is also represented as 50 kilo ohms. Means so 1 by 203.1 into 10 power 3 plus 1 by 50 kW 50 into 10 power 3 plus 1 by 50 into 10 power 3. Then you can solve this one. It gives that the total input side, the total input impedance, Ra dash is represented as 22.26 kilo ohms. Now we are going to calculate the output impedance R0 as per the low frequency model or a small signal analysis. The output impedance is represented as HIE plus R dash S by 1 plus HFE. So here we need to calculate. So where again, so here this is HIE is a known parameter and HFE is a known parameter. The unknown parameter is R dash S. But the given there only the RS. So hence we need to calculate. So with respect to the source resistance, we need to calculate the total input impedance. So hence I'm going to calculate this R dash S. So from that circuit, so the R dash S is represented as the parallel combination of RS resistance and R1 and your R2. So hence this 500 ohms is parallel with R1 and R2 resistances. R1 resistance is a 50 kilo ohms. Again, it is a parallel with R2 50 kilo ohms. Hence, so 1 by 500 plus 1 by 50 kilo ohms plus 1 by 50 kilo ohms means the parallel combination 1 by R1 plus 1 by R2 plus 1 by R3. So if we solve this one, the R dash S is approximately equal to 490 ohms. Now we need to substitute this R dash S in this value to determine the total output impedance. Hence, now I'm going to substitute this R dash S value to identify the output impedance of the common collector transistor amplifier. So hence, so now what is HIE value? HIE value is represented as 1.1 kilo ohms, means 1.1 into 10 power 3 plus R dash S. R dash S is the 490 ohms divided by 1 plus HFE value is 100. So hence this is 1.1 into 10 power 3 plus 490 by 101. Then you can simplify this one. Then it gives that R0 is equal to 15.74 ohms. This is the total output impedance R0. Now similarly, we need to calculate this R0 with respect to the load side. Means if we observe the output side and output port, the output port contains HF times of, so this is HFE. Then output side, it contains output impedance HO, or it is also represented R0. Then externally, we connected a load resistance RL. So hence to identify the total output impedance, so that should be defined as R0 is parallel with RL. So that is the reason. So what is R0 value? R0 is represented as 15.74 is the parallel combination with the load resistance, that is 2 kilo ohms, means 2 into 10 power 3. Then the parallel combination means 15.74 into 2 into 10 to the power of 3 by 15.74 plus 2 into 10 power 3. Then if you solve this ratio, it gives that R0 dash is 15.62 ohms. Then in a given problem, again we need to calculate so current gain as well as the voltage gain. So hence, to determine the current gain for a common collector transistor amplifier as per the small signal model analysis, the current gain is represented as 1 plus HFE times So hence we know the HFE value based on the given specifications. So HFE value is defined as 100, hence 1 plus 100, that is equal to 101. So here the current gain of the common collector transistor amplifier analysis, that is AA is equal to 101 or 100. And now similarly we need to calculate the voltage gain of common collector transistor amplifier. Hence, to identify this voltage gain based on the small signal model analysis, the voltage gain is defined as 1 minus HIE times of RA. So here we observe the input impedance and HIE is the given specifications. So hence 1 minus HIE is 1.1 kilo ohms, 1.1 into 10 power 3 by RA value is, what is RA value we observed? RA is, we got that 203.1 into 10 power 3 kilo, 10 power 3 ohms here. So you can simplify this one, means 203.1 into 10 power 3 minus 1.1 into 10 power 3 by 203.1 into 10 power 3. Then you can simplify this ratio. It gives that the voltage gain is equal to 0.9946. So approximately equal to, this voltage gain is approximately equal to 1. So to this point, based on the given specifications, we observe that input impedance, total input impedance, and output impedance, and total output impedance with respect to the load resistance, and we also observe that the current gain and the voltage gain of a given specifications. Then we'll see the another problem. Calculate the current gain, voltage gain, input resistance, and output resistance for the common collector amplifier shown in below figure. The transistor parameters are, means they are given that a small signal model parameters. HIC is 1.4 kilo ohms, HFC is 100, HRC is 1, and HOC is 20 into 10 to the power of minus 6. So hence the HIC means input impedance related to common collector amplifier. HFC means forward current gain. HRC is a reverse voltage gain, and output admittance, that is related to common collector amplifier. Then the given diagram is, so it contains, and they are using the common collector configuration, or it is also called as emitter follower circuit. For this given circuit, we have that the source resistance is 21 kilo ohms, and R1, R2 is defined as 20 kilo ohms, and emitter resistance is 10 kilo ohms, and the load resistance is 40 kilo ohms. We need to consider all these parameter values. Source resistance is 21 kilo ohms, R1 is 20 kilo ohms, R2 is 20 kilo ohms, RE is 10 kilo ohms, and RL is 40 kilo ohms. And along with the given transistor small signal model parameters are HIC is 1.4 kilo ohms, HFC is 100, HRC is 1, and HOC is 20 into 10 to the power of minus 6. Now, based on all these specifications, we need to calculate the current gain, voltage gain, input resistance, as well as the output resistance. So first I am going to analyze all the given specifications. The source resistance is 21 kilo ohms from the circuit as well as the given specifications. R1 and R2 is defined as 20 kilo ohms. Emitter resistance, if you observe the circuit, the emitter resistance RE is 10 kilo ohms. So hence RE is 10 kilo ohms. Then the load resistance is 40 kilo ohms. And apart from that, in the problem they mention the specifications come, the small signal model specifications, HIC, HFC, HRC, and HOC. Now we need to calculate current gain, voltage gain, means we need to calculate AI, voltage gain, input impedance RI or ZI, and output impedance R0 or Z0. So we need to determine these 4 parameters based on the given circuit and as well as the specifications. So first I am going to calculate this current gain in terms of small signal model of common collector amplifier. So there, this current gain AA is represented as minus HFC by 1 plus HOC times of R dash L. So if you observe this mathematical relation of current gain of a common collector transistor amplifier, where HFC is a known parameter and HOC is a known parameter, first we need to determine R dash L here. So hence from the circuit, if you observe the given circuit, so then if you want to find out the total output impedance at side, so this RE and RL is a parallel combinations, hence this RL dash is represented as the parallel combination with RE and RL. Hence, I consider this, the RL dash is represented as the parallel combination with RE and RL. So here RE value is 10 kilo ohms and RL value is 40 kilo ohms. Hence, the parallel combination of RE and RL is, what is RE value? RE value is 10 kilo ohms. 10 kilo ohms is a parallel combination with 40 kilo ohms. Hence, 10 into 10 power 3 into 40 into 10 power 3 by 10 into 10 power 3 plus 40 into 10 power 3. So if you say means 40 into 10 means 400 into 10 power 6 divided by 40 plus 10 means 50 into 10 power 3. Then if you simplify this one, it gives that RL dash is 8 kilo ohms. So means here then this is 5 and this is, so yeah, that is the reason RL dash is represented as 8 kilo ohms. Now we need to substitute this RL dash in this relation to determine the current gain of the common collector transistor amplifier based on the specifications. Hence, so this AI is represented as minus HFC by 1 plus HOC into RL. So then, if you observe the HFC value is here, the HFC value is 100. So hence, this is minus 100 by 1 plus, and HOC is 20 into 10 to the power of minus 6, means 20 into 10 to the power of minus 6, and RL dash is 8 kilo ohms, means 8 into 10 power 3. Then if you simplify this ratio, it gives that the current gain is 86.2. This is minus. Yep. Then similarly, we need to calculate. So where this is minus indication that is a flow of direction, current flow direction. So here this sign, minus sign indication is for the current flow direction for a common transistor amplifier. Now we need to calculate the input impedance. So that input impedance based on the small signal model analysis for this common collector transistor amplifier is represented as Ra is equal to HIC plus HRC into AA into R dash L. Now first we need to substitute HIC value, where HIC value is 1.4 kilo ohms, means 1.4 into 10 power 3 plus HRC, reverse voltage gain is a 1, and the current gain just now we observed that is 86.2, and R dash L is that is 8 kilo ohms, so 8 into 10 power 3. If you simplify this one, then it gives that Ra is equal to 691 kilo ohms. Then we need to calculate the voltage gain. The voltage gain contains AB is equal to AA into R dash L by Ra, where AA is the current gain and R dash L is the total output impedance across the load side, and Ra is input impedance. So now we determine this R dash L and Ra, then current gain is defined as 86.2. Hence, the current gain is 86.2. R dash L is 8 kilo ohms, 8 into 10 power 3 by Ra is 691 kilo ohms, 691 into 10 power 3. Then if you simplify this one, it gives that the voltage gain is 0.998. So up to this point, we observe that the input impedance, current gain, and the voltage gain, then also we observe the output impedance. So now to identify this output impedance, so first we need to calculate admittance, output admittance. So we know that the output admittance Y0 is represented as HOC minus HFC into HRC by HIC plus R dash S. So here, what is HOC? HOC is 20 into 10 to the power of minus 6. HFC is 100. HRC is 1. HIC is 1.4 kilo ohms. And R dash S. R dash S is, we observe that R dash S here. So first we need to calculate R dash S. So from the given circuit, so means if you observe this circuit, the given circuit diagram. So here, so from based on all these parameters, so we need to calculate R dash S. So hence from this R dash S, it is represented as RS is a parallel with R1 is a parallel with R2. So that is the reason I consider here. So R dash S is represented as the parallel combination of RS and R1 and R2. So means RS is, what is RS here? RS is represented as 21 kilo ohms. So 21 kilo ohms is parallel with R1 and R2. R1 is a 20 kilo ohms. Again, it is also parallel with R2. The R2 is 20 kilo ohms. Then if you simplify this parallel combination of these three resistances, then R dash is gives that is equal to 0.9 kilo ohms. This is R dash S value. Now we need to substitute to identify this admittance. Then we need to substitute this R dash S value in this output admittance. Hence, now I'm going to substitute the output admittance value here. So Y0 is equal to, so HOC minus HFC into HRC by HIC plus R dash S. HOC value is 20 into 10 to the power of minus 6 minus HFC is 100 and HRC is given that 1 and HIC is given as 1.24 kilo ohms plus R dash S. Just now we observed this R dash S, that is 0.9 kilo ohms, means 10 power 0.9 into 10 power 3. Then if you simplify this one, we then will so Y0 value is represented as 43,478 into 10 to the power of 6. Then by using this one, we need to calculate the total output impedance. Means we know that the reciprocal of admittance is nothing but your impedance. Hence, R0 is represented as 1 by Y0. So means 1 by the Y0 value is, what is the Y0 value here? 43,478 into, so 43,478 into 10 to the power of 6. Then it gives that is R0 is equal to 22.99 ohms. So the R0 value is represented as 22.99 ohms. Now we'll see the another problem. A voltage source of internal resistance Rs, that is 900 ohms, drives a common collector amplifier using load resistance RL is 2000 ohms. So the common emitter H parameters are HIE is a 1200 ohms, HRE is a 2 into 10 to the power of minus 4, HFE is a 60 and HOE is 25 micro ampere per volt. Compute the current gain, input impedance, voltage gain and output resistance using approximate analysis as well as the exact analysis. So we need to identify the two analyses here based on the given specifications. We need to choose approximate analysis as well as the exact analysis. So now first actually, so if you observe this one, and this problem is related to a common, so means I will say this is common collector amplifier, but the given H parameter models are related to common emitter amplifier. So that is the reason first we need to convert this a small signal model or H parameters of common emitter configuration to common collector configuration. So that is the reason first I am going to convert the common emitter H parameter values to common collector H parameter values. So for before that, first I'll note down this the given specifications, like the source resistance is 900 ohms and the load resistance is 2000 ohms. HIE is 200 ohms and the reverse voltage gain HRE is 2 into 10 to the power of minus 4. HFE is 60 and HOE is 25 microamperes per volt. So all the given specifications are related to common emitter amplifier, but we need to identify the parameters related to common collector configuration. Hence here I am going to use the conversion formulas from the common emitter to common collector. So means if you want to identify this input impedance from the common emitter, that is equal to HIC is approximately equal to HIE. Hence here I am representing this HIC is equal to 1200 ohms. Then similarly, HFC is represented as minus 1 plus HFE. So hence HFC is equal to, this is minus 1 plus HFE is given as 60, hence it is represented as minus 61. And HRC, in a common collector amplifier, we need to assume that the reverse voltage gain is always equal to unity. Then is the reason HRC we assumed as a 1. And HOC, or that is equal to HOE, that is means from the common collector configuration, HOC is approximately equal to HOE, hence that is equal to 25 microampere per volt. So these are the conversion formulas. Based on these conversion formulas, we observed that the H parameters related to common collector transistor amplifier. So now by using these given specifications and the H parameter model values, now we need to calculate the input impedance, current gain and output voltage gain and output impedance. Now first I am going to calculate the current gain of common collector amplifier. And here we know that the current gain is represented as minus HFC by 1 plus HOC times of R1. So now this is minus HFC, we observe that minus 61, hence minus of minus it becomes plus, minus of minus 61 by 1 plus HOC. HOC value is 25 into 10 to the power of minus 6 into the load resistance RL. In a given problem, the load resistance is given as 2000 ohms, means 2000, or you can write 2 into 10 power 3. Then you can simplify this one, it becomes 61 by 1 plus 25 into 10 power minus 6 into 2000. And based on the specifications, after this simplification, the current gain is equal to 58.095. Now we need to calculate the input impedance of the common collector amplifier. And based on the small signal model analysis, the input impedance is represented as HIC plus HRC into AA into RL. So if you observe this one, HIC, so is we calculated, and HRC also we calculated. The current gain just now we observed, and the load resistance is 2000 ohms. Now you can simply substitute these values. HIC value is 1200 ohms plus HRC, reverse voltage gain, that is 1. Current gain is 58.095 into the load resistance is 2000. So means this is 1200 plus 58.095 into 2000. Now you can simplify this one. It gives that the input impedance is 117.39 kilo ohms. So means the total input impedance is 117.39 kilo ohms. Now similar to that, we need to calculate the voltage gain of the common collector amplifier. So based on this small signal model analysis, the voltage gain is represented as AA times RL by RA. So here AA is 58.095, RL is given as 2000 ohms, and RA is, we observed that 117.39 kilo ohms. Hence AA value is 58.095 into RL is 2000 divided by the RA value is 117.39. Okay, 117.39 into 10 power 3. Then you can simplify this ratio. It gives that the voltage gain is 0.98. Now we need to calculate the total output impedance. Now we know that the output impedance is the reciprocal of admittance. Hence, first we need to determine the admittance. The Y0 is equal to HOC minus HFC into HRC by HIC plus RS. So here, first we need to identify that parameter there or not. HOC is a known parameter, HFC is a known parameter, HRC is a known parameter, and HIC is a known parameter. RS is the given specification. Hence, simply can substitute these values. HOC is 25 microampere per volt, means 25 into 10 to the power of minus 6 minus HFC. HFC is minus 61, means this is minus 61 into HRC is a 1 divided by HIC is 1200 ohms. 1200 plus RS value is 900 ohms. Then you can simplify this ratio. It gives that the Y0 is 0.029. So this is ohm inverse. So I written the units here. The admittance units are ohm inverse, that is nothing but ohms. Now by using this admittance, we need to calculate the output impedance R0. So hence, we know that R0 is the reciprocal of admittance. Hence, R0 is equal to 1 by the Y0 value is 0.029. Hence, this is 0.029 ohm inverse. Then R0 value is equal to 34.48 ohms. Now, this is a exact analysis. Now we'll see approximate analysis. So in the approximate analysis, we should neglect a reverse voltage gain. So then based on that, the current gain in approximate analysis, the current gain of a common collector transistor amplifier is directly represented as 1 plus HFE. So hence, so this is 1 plus HFE value is 60. Hence from this, the current gain is represented as 61. Hence, the current gain is represented as 60. Now, similarly, we need to calculate the input impedance Ri. Ri is represented as HIE plus 1 plus HFE times of Ri. So, HIE means 1200 ohms plus 1 plus HFE means 1 plus 60 into RL value is 2000 ohms, means this is 2000. So, means this is 1200 plus 61 into 2000. Then after the simplification, the RA is represented as 123.2 kilo ohms. RA is represented as 123.2 kilo ohms. Now in the approximate analysis, again we need to calculate the voltage gain. The voltage gain is represented as 1 minus HIE by RA. So hence this is 1 minus HIE means 200 ohms divided by RA value, we got that 123.2 kilo ohms. So means that this is 123.2 into 10 power 3 minus 1200 divided by 123.2 into 10 power 3. So after this simplification, we'll observe the voltage gain is 0.99, that is approximately equal to 1. The voltage gain is approximately equal to 1. Now again, we need to calculate in approximate analysis, we need to calculate the total output impedance R0 is represented as HIE plus RS by 1 plus HFE. So means HIE value is 1200 plus RS value is 900 by 1 plus 60, means this is 2100 divided by 61. Then after the simplification, R0 is 34.48 ohms. R0 is represented as 34.48 ohms. So up to this point in this session, today we observed that some of the problems on common collector transistor amplifier analysis using low frequency model. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.